In this video, we're going to go over another example of transforming non-parent functions. So let me just start off with an example. So let's just say example 2, and then I have some function f of x, which it's going to be negative 2, and then it's going to be a square root function. So inside the square root is going to be 6 minus 2x square root, and then plus 1. And then I'm going to transform that to some function called g of x. And the transformations are the following. So it's a reflection over the y-axis. Okay. And then there's going to be a stretch in the x direction by 3. So it's not by 3, by a factor of 3. And then there's going to be a stretch in the y direction by 4. And finally, translate by 4 to the right and 2 down. Okay? And then the question, as always, is find an expression for g of x. All right, so we're going from f to g, and here's f, which is a non-parent function, and these are the transformations that are going to take us from f to g, and we've got to find an expression for g of x. So before I start, remember the important thing is that we need to sort of define the stretch in terms of f. So anyways, first let's start with the reflection. The reflection over the y-axis, that affects the x's, so it's going to be f of negative x. The stretch in the x direction, that's going to be f of 1/3 of x, right? And then a stretch in the y direction by 4, that's going to be 4 times f of x. So like what I've written here in green, it's not going to become relevant to us now, but in our final step, when we're trying to find an actual expression for g of x, that's when this will become important. So anyways, let's start step by step into finding g of x. So if you remember the first step was to write a factored expression for f of x. So f of x is equal to negative 2, 6 minus 2x plus 1, okay? And if I factor it, it's going to be negative 2 and negative 2, x minus 3, square root plus 1. So that's f of x right there. So the next thing is let's sketch it. Let's see what an original one looks like. So let's do that right there. And so we have 3 to the right, let's just say there, and up 1. Okay. And remember, as I said, when we're sketching, and since it's a rough sketch, the stretches won't really affect the direction, but the reflections will. And since it's a reflection across the x and y, it's pretty much going to go like this. All right, so that's our original function f of x. Now let's go through the transformation step by step. So the first transformation is a reflection over the y-axis. So if there's a reflection over the y-axis, that means all the x's are affected but not the y's. So in other words, this 3 will become negative 3, but the 1 doesn't change. So in other words, this point here will be reflected there, and then it's just simply going to go like this. It's just a reflection over the y-axis, and so it looks, sort of in the exact opposite direction of the y. And then what I'm going to do is I'm just going to erase the yellow. Oops, that was too big. Let me just rewrite this again. So this is going to be negative 3 over here, and there was an arrow there. So what I'm going to do is I'm going to erase this yellow, which is right there. All right, and I'm going to also erase that 3 over there because I don't need that anymore. Okay, perfect. And then now let's go to the front. So we've taken care of the reflection. The next thing we need to take care of is the stretch in the x direction by 3, which means all the x values get multiplied by 3. So if all the x values get multiplied by 3, then this negative 3 here will end up being negative 9. So it ends up being -9, and that 1 stays put. So it sort of stretches in the x direction, so it just looks kind of like this, okay? And what I'm going to do now is I'm going to get rid of the blue. Again, use a pencil, you know, just to kind of show you the steps that we're taking. Or you can do it step by step if you want to show different graphs. So anyways, this is the next one. We've taken care of that. So a stretch in the x direction by 3, so we've multiplied everything by 3, and we've got -9. Now, we want to stretch in the y direction by a factor of 4. So that means all the y's will now get multiplied by a factor of 4. So this 1 gets multiplied to 4. So this will become 4 over here, and this point will simply go up there. So we're just going to multiply everything by 4. So it's going to end up looking like that. And then I'm just going to erase the yellow. So I'm going to erase all of this. That's the old function. Boom. And I'm just going to connect that right there. Oh, I should have stuck with that -9 because that -9 never changed. But anyways, okay. So -9 and 4. Let me just erase this 1. So that's the starting point, but we still have a few more transformations left. So we've taken care of that. And now translate 4 to the right and 2 down. So if I move this 4 to the right, it'll become -5, because -9 plus 4 is -5. So let's just say it's -5. And it says 2 down, so it'll become -2. Oh, no, it'll become +2 because, oops. It'll become +2 because 4 minus 2 is 2. And so this will become our origin, or a new starting point, and then just sort of go down in that direction. And I'm simply going to erase the blue from before. Erase the blue from there. Erase that there. And there we go. So that is our g of x. This is basically our g of x right here. All right. And what we're going to do now is figure out an expression for g of x. So in order to do that, what I'm going to do is I'm just going to write the f of x first. So here's f of x, which is -2, and then the square root of -2 x minus 3 plus 1. And then I'm going to write our, oh, let me put that in yellow. So then here's g of x, which is equal to something times something. Okay, the thing is, I know the starting point of g of x is -5 and 2. So what this is going to be in the factored form, is going to be x plus 5, and then it's going to be plus 2 on the outside. So what we have to figure out right now is what are going to be the coefficients in front of the square root and the coefficient in front of this x inside. So now this is where that writing the stuff in green before is going to come in handy. So since this a reflection over the y-axis, that affects the x's, so it's going to be negative, and then a stretch in the x direction by 3, so it means all the x's get multiplied by 1/3. So in other words, all the x's get multiplied by -1/3. So since what's inside the function is going to affect the x's, this has to be multiplied by -1/3. This 2 here has to be multiplied by -1/3. And looking in the y direction, there's no reflection over the x-axis, so that doesn't affect the y's. But there is a stretch in the y direction by a factor of 4. And what's going to happen is that this -2, because it affects the y's, is going to be multiplied by 4. So what does that mean in terms of our final expression? Well, -2 times 4, well, that's -8. And -2 times -1/3, the negatives cancel out. So it's simply going to be 2/3, and we are done. So our final expression for g of x is -8, square root of 2/3, x plus 5 plus 2, and we're done. All right, so hopefully that explained to you how we go from f of x to g of x, basically through a visual way. And don't forget this last step where we have to take care of the coefficients outside the square root and also inside the square root. I'll see you in the next video.